Hi everyone, this video is on exercise 13C question 8. So we are given the height of an arrow from the top of the castle, which is modeled by the function f of t, where f of 0 is equal to 35, and we are also given the derivative of f of t. So the derivative is equal to minus 9.8 t. In the first part, we want to find f of t. So when we are given the derivative and we want to find the function, we need to integrate the derivative. So in this case, to find f of t, we integrate minus 9.8 t with respect to t. So this simply gives us minus 9.8 divided by 2t squared plus c, which is equal to minus 4.9 t squared plus c. So we are given a point, and whenever we are given a point, we need to find the constant of the integration. So we can first rewrite this as f of t is equal to minus 4.9 t squared plus c, and now we can use the fact that f of 0 is equal to 35. So that means f of t is equal to 35 when 0 is substituted into the function. So minus 4.9 times 0 plus c. So this gives us 35 for the value of c. So f of t is therefore equal to minus 4.9 t squared plus 35. So this is f of t, and the answer to part A. In part B, we want to determine the height of the arrow when t is equal to 1.5. So essentially, the function, the value, of f of t, the output of the function is the height. So this simply means that we just need to substitute 1.5 into the function to find the height. So for part B, we just need to find f of 1.5 because the output of the function is the height. So we have minus 4.9, 1.5 squared plus 35, and this is equal to 23.98 meters. So that's the height of the arrow when t is equal to 1.5. And for part C, we want to estimate the time it will take the arrow to hit the ground. So here we just need to think about the situation. Basically, if the arrow hits the ground, then that means the height of the arrow is 0, right? So in other words, if the arrow hits the ground, then the output of the function is 0. So we set the function equal to 0. So like this, minus 4.9 t squared plus 35 is equal to 0 because when the arrow hits the ground, the height is obviously 0. So we just need to solve this equation to find the value of t. Okay, and now that we have this equation, we just need to solve this quadratic equation. So we can rearrange that to have minus 4.9 t squared is equal to minus 35. So multiplying both sides by -1 and then dividing by 4.9. We are going to have 35 divided by 4.9, and then we just take the square root of this. So we get. So remember that when we solve quadratics like this one, for example, we have t squared is equal to 25, then we get two solutions, right? Plus or minus 5. So this is the same case. So we get two solutions for the value of t. One is 2.67 and the other one is minus 2.67. But in this question, t represents time and time must be positive. So the only solution is equal to 2.67 because time is always positive. So this one is invalid. And finally, we want to state one assumption used in our calculation. So one of the assumptions is that in this calculation, we assume that the ground is flat. Because if the ground isn't flat, then the height is going to differ when the arrow hits the ground, in the case that the ground isn't flat. So the height is going to differ, so that we can't exactly do the calculation like this. But since here we just assume that the ground is flat, then we can simply set the output or the value of f of t at 0 and then just solve the equation. So we can just say that we assume that the ground is flat.